Hi, good afternoon. My name is Carlos Lastrilla, a solutions engineer for CADGROUP Australia. Today's webinar is going to be about Fusion 360. Now, before I get started, just wanted to grab a quick poll to see what current CAD product you're using. Yep, if any. Just wanted to take 1 minute for this. Right, okay. Now, while I'll be starting off with PowerPoint, I'll be jumping over to some live product demos, some videos, and some images throughout the presentation. And if you could reserve your questions till the end, where I'll open the floor to questions, that would be much appreciated. All right. Now, I can see here that we're predominantly a group with 3D users. And yeah, for today's webinar, let me just, okay. I'd like to start off by giving you some context that will hopefully lay the background of why Fusion 360 promises to be such an important tool in your toolbox. Now, if we look at the current product development process, we will see that it's usually very linear and over-the-wall in nature. Now, based on identifying a specific requirement or market need, manufacturers create a unique product concept. Then we go on to the process of design, and where we possibly might need to make several design changes to make the product idea or make the product basically more profitable and manufacturable and basically able to take it to market. Now, once we do that, we produce the product using various manufacturing techniques. Then we go through a period of selling the product where we have customers who will hopefully buy our products. And not only buy, but operate it and eventually retire it. Now, this is what we call as the traditional product life cycle, where we get a product with a fixed product value. Now, that product value is the sum of the input costs plus business costs plus any margin we might want to retain. Now, we can try to use cheaper materials or improve the process of manufacturing or the process efficiency of the business so we can reduce the product of the component and compete that way. Let me just see, make sure, okay, sorry, I got distracted there, but when we try to do that, when we try to reduce the cost of our product, that usually makes our product a commodity. And when we're talking about commodities, these are usually won on lowest price wins terms. An alternative to this is we can pursue a differentiated strategy that basically, if we take that margin and put it back into product development, that allows us to basically innovate and create a more competitive design based on product differentiation and separation. So how do we do that? Now, to do that, we need to change the linear process. First, at concept, we need to think about how to personalize or customize that product. So whether we're talking about the consumer product for an individual or an industrial machine, which you configure for a customer, the more concisely that we meet the needs of the customer, the more premium we can charge for the product that we take to market. Now, when we talk about design, it's all about iteration and collaboration. Now, we need to be able to quickly create and evaluate designs across multiple team members with various inputs. Now, there's a need for technologies that allow users to work on a single product or project, even though they were on 2 different continents. It would seem as if they were co-located. We also now have better methods of manufacturing. Factories are becoming more and more configurable and agile. Additive manufacturing techniques like 3D printing is on the threshold of becoming a mainstream manufacturing method. These improvements allow us to overcome the usual limitations of the economies of scale so that we can start to create more personalized products for the customer. Now, when we sell the product, it's about moving towards the customer's experience, which usually starts when the customer first discovers your brand, usually either through a website or word of mouth or catalogs. and then personalize, and then you can actually personalize and configure the product. Or sorry, I should say the customer, your customer can actually personalize and configure the product. Now, a good example of this is an earphone manufacturer in the U.S. where when you buy their earphones, they ask you to download an app on your phone and then to take a picture of your ear. And based on that picture of your ear, they can actually custom create like a fitting for their headphones or for the earbuds that's actually personalized or perfectly suited for your own ear. And basically, you know, when you get that product shipped to you, it's customized for your own use. Now, this experience, this personalized experience, should extend beyond the point of sale, and that's where connected services actually brings huge opportunities, because with connected services, we can move beyond the idea of a fixed product value. We can start to get into things like preventive maintenance as extra services, or even predictive maintenance, where the machines we build actually tell us when there is a problem. Then we show up at the customer's doorstep to fix that problem, or maybe even fix it remotely. If you think about Tesla cars or Tesla vehicles, and you know how they can actually deploy remote updates to their cars to improve performance or to fix issues. So that means, you know, if you're a Tesla owner, you don't necessarily have to go to the car shop, to the car yard to actually have your car fixed. Now, the more we take advantage of this process, the higher, the more value we can get from our product over its lifetime and beyond. And because we're basically doing what we call a product as a service. So we've got increased lifetime value for that product. But you know, the real kicker is when we get that data together that we gather, because we're in connected services, when we get that data together and we actually feed that back to the start of the development process, where we have an agile, iterative, and development process. That's Autodesk's vision of the future of making things. If we look around us now, and let's say if you bought an electronic gadget recently, you probably have seen it happening already. Now, to meet the challenges of the future of making things, that is where we need a product innovation platform. Now, at the heart of that product innovation platform is Fusion. Now, today, Fusion unites all of the various design disciplines, whether it's industrial design or mechanical engineering or electronics, or eventually software, where we unify all these processes in one technology platform. Because, quite honestly, being a manufacturer, we're not really paid for the models that we make. We actually need a physical product. And that's why Fusion includes CAM capabilities. Autodesk is also working on connecting the product to the end user. So basically, our product that's on the end user side, it can get connected to your company, to the manufacturer, through technologies like the Internet of Things or C-Control, that we can basically bring all these together and close the loop. So Fusion is not just a CAM package, a CAD package, or even an analysis package on its own. It's a brand new category. It's a innovation platform, and that's what really differentiates it from everything else on the market. And that will also give you the tools to give you true competitive separation in the market. It's truly integrated. Now, Autodesk is also making tools beyond what we have today and geared towards the next generation of technology. We've got, for example, generative design, where the computer generates a design based on the parameters you define. Then it's got the ability to use mass parallel compute on the cloud to solve and provide you with the best solution in evaluating your design. There's also industrial additive techniques or capabilities which enable us to print those materials or even print those products, or, you know, even going to the point of printing 3D, printing your 3D models in metal. There's also the capability to connect these products together through the Internet of Things, like the concept of the Internet of Things that basically close that whole loop. Now, for this webinar, we're going to have a look at a specific area of the product innovation platform, which is Fusion 360. So Fusion 360 is a cloud-powered computer-aided design, engineering, and manufacturing tool. And in today's overview, and I'll stress the word overview, we'll have a look at the different aspects of Fusion 360. We're planning to have future webinars and videos dedicated to a deep dive of specific aspects. And there are also heaps of online resources which can help get you to started. So today we'll have a look at Fusion 360 as it relates to modeling, simulation, manufacturing, presentation, and data management. All right, let's have a look at modeling. So Fusion 360 combines both history-based parametric modeling and direct modeling, where you can define the model using traditional based features and then enhance this with on-screen push and pull techniques. There's also free-form modeling in Fusion 360, which uses T-spline technology, and you can use this to create create and modify complex subdivisional surfaces, so that you can create forms that are organic, more organic looking, and more ergonomic. Fusion 360 also allows us to bring in OBJ and STL files from 3D scanners. So if you bring these, if you have any experience in 3D scanning, when you scan something, you more often than not, you need to make edits and repairs to the meshes, and Fusion 360 has those tools. And Fusion 360 is not only a part modeler, but it's also an assembly modeler, which means that you can bring parts together and use joints to simulate motion and create motion studies to create a basic kinematic analysis. You can also bring in a wide variety of formats. I think to date there are something like 100 different formats that you can bring into Fusion 360. Or sorry, not 100, I exaggerated, about 30 different formats. There are 160 different post-processors in Fusion 360. But yeah, with that, let's have a look at the actual, some product demos. So if we have a look at the bracket here, this is a bearing bracket inside Fusion 360. And for, say, the 3D users, particularly inventor users, you'd be very familiar with the concept of everything starts off with a sketch. Okay, so you've got the sketch there for different features, and then you convert the sketch into features. Now, because it's a parametric history-based modeler, you have a list of the different features here on the tree, and you can actually roll back specific elements or features to actually see or see how the model was built. So if I go back to the very beginning and click play, it gives me a preview of how that model was actually built, what sketches were created, what features were created, what was extracted. Oh, I think my recording just paused. Okay, let's play that again. Okay. Yep. Yeah. Okay, let's do this step by step. The reason this is happening is because I'm recording this webinar, and that recording function is interfering with the actual model creation. So I'm just doing this step by step. Let's create a face, create a sketch, create a feature. And as you go on, you actually see that that model is built. All right. Now, you've got a history tree there. Again, everything is parametric. You can edit that feature. You can change the chamfer there. Now, if, for example, I want to change the bore, instead of having to go in to look for that specific feature, I can use the direct modeling functionality. And that's over here in the press pull. So say I want to change this bore diameter. I click on that face. Maybe I just want to make it, thicken it by about 5 mils. Or say I can click on this face here and then just decrease it a bit, or maybe even increase it a bit, and click OK. So those are the functionality that's available right now inside Fusion 360 in terms of making the modifications to existing geometry. Now, there's also the capability to go into the sculpt or sculpting. So if I just click on this, I go into the sculpt environment, click OK. Let me just undo these changes that I've made earlier. Okay, so I've got the sculpt environment there. Maybe if I wanted to make this, excuse me, this handle a bit thicker, I'm going to click on these faces there, and I'm just going to drag that. See, it actually, because I've defined a symmetry plane here, it does it on the other side as well. Maybe I want to just change the angle depending on how I see it. Happy with that. Create another modification. Maybe I just want to make this a bit bigger here. So basically, you're using T-splines to actually make a more organic or more ergonomic form of your model. Now, there's also, in Fusion, we also have the assembly modeling, and I've got a reciprocating saw here. And you can see here that I actually have a sub-assembly there, and I've got several different parts there. I've got the side trigger, the trigger, and housings, which are currently now grayed out so that I can show you the internals of this. And because it's an assembly modeler, I actually have the capability to define motion. See here, if I rotate this gear here, you can see that it's actually doing that rotation even to the point of mimicking the motion, or simulating, I should say, simulating the motion of the reciprocating saw. All right. So that's the modeling functionality. Now we'll go on to the next part, which is simulation. So Fusion 360, you can do a variety of simulation studies to analyze your design under different load and constraint and even material combinations. So there are several different studies available. You can have linear static analysis to calculate for displacements, stresses, reaction forces due to applied loads. You also have modal analysis to find the natural frequencies of your components. You have buckling analysis, where you can analyze for loss of stability of components like frame members. You also have thermal stress and thermal analysis and thermal stress analysis, where in thermal analysis, you analyze the temperature distribution in your design, and then you can combine that with static stress to further see what stresses your designs undergo when subjected to thermal loads. Now, there's several options when solving. You can solve locally, or you can have the Autodesk cloud servers to do the solving for you. So, for example, you've got a model, and say you've got 8 gigabytes of RAM on your machine and one 2.5 gigahertz CPU. And for small parts and assemblies, let's say about 100,000 elements in the mesh, this might take you a couple of minutes to solve locally. Now, if you solve this in the cloud for a small assembly or part like this, it'll probably take you the same time. But when you have larger assemblies, for example, that has got more mesh elements, and if you try and solve it locally, this might take you 4 hours. Now, when you're solving locally, what that happens, it uses all the resources on your machine, and so your machine is slow, it's sluggish, you'll hardly be able to use Fusion or any application on your machine. Now, if you use the cloud solver, which has access to more memory and access to more CPUs, this will probably take about an hour. But at the same time, while it's processing in the cloud, your PC, or the performance of your PC, isn't impacted. So while you're actually doing the simulation in the cloud, you can do more modeling in your side on your PC. Now, the cloud solver does consume cloud credits, and it's typically they charge 5 cloud credits for every solve or every solution that you try to apply onto the cloud. Now, as of today, there are several new studies available in Fusion 360 as fully functional previews, and we're hoping to see this in full production mode in the next few months. But right now, again, they're fully functional previews. We've got event simulation, which allows you to investigate the effect of multi-body interactions in your components. So, for example, you're looking at when you're creating, say, a plastic fitting, and you're doing some snap fits for that fitting. What does that actually look like in terms of the motion and the stress? Stuff like drop tests, you can simulate that with event simulation. You also have nonlinear analysis, where you can perform stress analysis for components, and you can take into account large deformation or nonlinear material behavior, like certain plastics or rubber, or typically when the material is stressed beyond the yield strength. There's also shape optimization. This, I think, is a really cool tool. It helps you design lightweight and structurally efficient parts. So it gives you computer-generated design alternatives based on your existing design and load conditions. So with that, let's have a look at the product itself. So again, I've got a very simple support beam here. And within the Fusion environment, I've got the model. I'm right now in the modeling environment. I can go on to the simulation environment where I've already created a static stress study here. So if you have a look at this, I've got a load case here. So it shows me all the components inside my model. It's basically a beam. I've got the material. Right now it's steel. I can assign multiple materials to it to see the effect of the different materials. And then I've got different load cases. So I've got, for example, a load right now. Okay, if I edit that load, okay, I have roughly 3,000 newtons on that load, on that face, on that specific face there. And I've got some constraints. Basically, I'm saying it's fixed here at the end. And then when I run those results, when I solve those, okay, that's what we get. So I can see how much stress it's a von Mises stress that's being displayed here, minimum and maximum points. I can see, for example, if I put in a safety factor or what my safety factor is for this particular design. I can see how much displacement there is on that beam. I can see some reaction forces, how much those reaction forces are at the ends. And I can see some strain as well. Now, all of that is done through that simulation environment. And just to show you, when you want to solve for it, you've got several options. You've got the option to solve it locally, okay? And when you hit solve, it will load the Nastran solver locally and then do the processing locally. Or you've got the option to solve it on the cloud. And when this happens, it gives you a credit, idea of how many cloud credits are actually going to be used for that simulation. So right now, how many cloud credits you have remaining and how many is going to be used. And you click solve. It will now submit this to the cloud, and then you'll get a notification once that simulation is complete. Now, we also have a different kind of, let's see, okay, this is the X-chop, which is a simulation of, for example, an axe hitting several boards. Okay, my orientation is a bit off. Okay, so let me just constrain my orbit a bit. Yep. Yeah. Okay, so I've run the simulation already, and right now, because it's a preview, it's only available on the cloud. But to give you the results of that, I'm going to animate that and hit play. And it's going to show you the stresses at those points. It's going to cycle through those steps. And you can stop it at a specific step to show you what the stresses are at that particular step on impact. Okay. Now, the last one is also really cool, I think, is the shape generator functionality. And this is something that, for example, in this case, I've fabricated or I've designed an iPhone holder. And basically with the intention of having to 3D print this. So what you can do with this is that you can actually, once you've modeled it, it's a very engineering-based design, if you allow me to say that. If I go onto the simulation tab, what you do with shape optimization is basically you define an optimization target, and I'm gonna, sorry, it's over here, and then say I want a target mass, reduce your target mass by 30%, at least 30%. And so what you do is you have your target mass, you maximize the stiffness, and you define what we call preserved regions. So what preserved regions do is that basically I'm telling the computer, the solver, not to touch these regions because I want these regions to basically remain that same shape, because like in this case, they're screw holes, so I want to make sure that they're maintained. And then I apply a load to it, all right? And then I solve it. So when you solve this, it gives me this mesh here, this preview, the load path of this particular bracket. And once I have this particular load path, I can actually now promote these results to my model. So if I go back to my model here, I already have that promoted, and it's basically this shape here. It's been promoted as a mesh object. And once it's promoted as a mesh object, I'm just going to play through all the other steps that I've actually did to, let's go all the way to the end. Yep, to create that. And then once you have that mesh object overlaid, you can then start creating sketches and features until you get that final form, which is this one. And I'm just going to turn off that body for that mesh body. And that gives you that final model that you have. So when I 3D printed this, the very first design that I made, which was this one, this consumed roughly about 26 grams of material. By the time when I 3D printed this one, this particular one consumed about 12 grams of material. So you can see the effect straight away of something like this. All right, we'll go on to the next portion, which is talking about the CAM environment, or the computer-aided manufacturing inside Fusion 360. So with Fusion 360, you can create two-axis, or which is basically profile cutting, 2.5 axis, which is basic machining with steps, and then you can also create 3-axis toolpaths. You can also do 3+2 machining, also known as positional 5-axis machining. You can do 4-axis machining. So if you've got an A-axis on your CNC, you can use this for indexing or wrapping toolpaths. Fusion 360 also has full 5-axis simultaneous machining. It also has turning machining options, turning machining operations, I should say. And it has a 3D printing machining option, or it's basically via Autodesk Print Studio. So if I just show you a quick video of this particular functionality, or no, not a video. Let's go to the live product demo. Okay, so if I have a look at, bear with me here. Okay, this particular model here. Okay, so you can see there, I've got here a vise that's actually been imported from the manufacturer. There's several vices that are available, and there's even several tabletops for the major machining or CNC brands. Now, you can see here that I've got my stock material there as well. Okay, and I also have my gearbox cover, which is basically what I want to machine. So I'm just going to go on to the CAM environment. Okay, and what you'll notice is I've got here several setups already, and I've got several toolpaths generated for me. So I basically generated these, or created these toolpaths, selected what phases I wanted to machine, and I'm just going to generate the toolpaths for this. And then we can also do, okay, so roughing is still doing it. Let's wait for this to finish. So I've got several different setups here as well for the different phases that I need. Now, as with any CAM software, you create certain setups. You have to make sure that your tool library is basically correct. You can customize your own tool library. There are several sample shank holders there, and several mill size or bit sizes there for you, and several different kinds of bits. So once you have all that set up, then you generate the tool faces or the tool paths, and then we can simulate that process. So I can see here all those tool paths in the simulation. So I can show the tool, I can show the tool path, I can show the stock, for example. And I want the stock to be a bit more transparent. So if I hit play, it now shows me the machining process. And I'm just going to hide the tool path so it doesn't obscure our vision. But it's actually, when you're machining, you should actually have a look at the tool path, or when you simulate, you should actually have a look at the tool path. So it's proceeding. Let's just increase the speed a bit more. So as you can see, it's actually cutting off the stock and showing you the different phases as well for that stock. There's also a stop on collision option. So if it's going to collide with any of your other, let's say your vise or any of your fixtures, then it's going to give you a warning. Oops, sorry. Yep, so finishing that off, let's turn off the toolpath. Right, and it's done. So you can also get the information or the statistics. So it took, say, 8 minutes of actual machining time, the machining distance if you were computing for the life of your tools and so. Now that's basically your basic 3D machining. There's also the turning functionality. So again, I've got this item that I want turned, so I'm going to simulate that from the stock, hit play again, and you can see that it's actually simulating the turning process. Let's do it a little bit faster. Okay, you can show the toolpath as well. And the preview here at the bottom actually shows you each specific operation. It's divided into operations there. It's now just creating those threads. All right. So that's the CAM functionality of Fusion. Now, if you just go back to our presentation, let's have a look at the presentation capabilities. So again, while Fusion 360 is the tool of the future, 2D drawings are not dead. At least they're not yet dead. But Fusion 360 can create 2D shop drawings, and you can create, say, the usual usual orthographic projections, section views, detail views, and isometric views with all the usual annotation tools. You can also create animations of your models, so you can show basic assembly or disassembly procedures. There's also a rendering engine which uses ray tracing, which will give very good results. And you can do either a local render or cloud render. And as usual, cloud rendering does consume cloud credits. And the number of cloud credits that you consume depends on the size and resolution of the image that you want to render. So let's have a look at this specific functionality. If I go here to the, let's go back to my bearing bracket. I'm just going to create a basic 2D drawing off of this. And what I can do is click on that new drawing. So from this particular design, or I can go on to, oops, not that button, but this button here, and then drawing from design. So I'm just going to save this first. And this is something that you'll notice every time you save in Fusion 360, and we'll get to this later, you're actually creating a new version because it also has version control. So I'm going to create this, created, I can't spell, okay. So create a drawing, so choose that. I'm going to create a new drawing from, I'm going to use a template from scratch using ISO standards and using a millimeter unit A3 size. Click OK. You can customize this template, by the way, which is something that's been improved. Okay, so let's say I want to grab my right view, and I want to change the scale to, say, 1:8, make it a bit bigger. Okay, click OK. And then I can project that view so that I've got my orthographic views. Okay, just the usual stuff there. And then I can create, say, section views. So say I want to create a section from here. Okay, just create that there. Maybe the scale I want it to be a bit bigger. Click OK. Move that over there. Yep. Okay. And you can also create detail views. So say if you want to show a particular detail in your model, I want that to be, say, 1:3 as well. And then you have all the usual annotation tools as well for you, available for you. So you've got center lines. You've got the power dimension tool, which is, if you're an inventor user, you'll probably be very familiar with something like this. Or even an AutoCAD user, basically just click on vertices that you want. Or in this case, let's say just that single tool you can use to create radiuses and dimensions and diameters. And so basically, oops, You've got all the object snaps as you need. So that's your drawing environment within Fusion 360. Now you also have the capability to create some animations. So I'm going to open up this particular one here. And again, this is a model of a vise. And what I can do is I can go into the model tab and say go to the animation environment. Now within this animation environment, I've created several views, but it's quite simple to create your own view there. So if you've used the inventor presentation environment, it's very similar to that, where you've got a camera view, you set camera views, and then you apply transforms to components, where I'm going to drag this out there. And each of these transforms will actually be an entry into your timeline. So you can say that's going to take 3 seconds to move from here to there. All right? And you can also say that once it gets there, okay, I want to turn off or fade it out. So I'm going to say that this one, I'm going to fade it out a bit. So if I now play my animation, okay, then it fades out. So it's something, I've created one here, and to show you what that looks like from the beginning, and I play that. So it's just a very basic animation on this assembly, right? Now, once you've actually created that animation, you can publish this several ways. So if you hit publish, you can publish this to the current storyboard at a certain resolution. Oh, sorry, not publish it to the current storyboard, but publish the current storyboard. Okay, you can publish it to the cloud and then as an AVI, and then you can also save a local copy into your machine. Now, when you save this, that's obviously going to start rendering it locally. But I've done one already, which is this one, which is, I think it's quite good quality as well. So this is an AVI file, which is roughly 9 megabytes in size. If you look at the visualizations, it's quite nice. Okay. Now, there's also a rendering engine here. If you click on render, and with a rendering engine, it's quite straightforward. You can choose appearances for that particular parts of your model. You can choose specific environments or scene settings. We've got some scene settings over there. And then this is the point where you can actually start to, for example, let's just change the appearance of this. I'm not too happy with the base here. So let's have a look at what are metal, say steel, let's say rough. I want to use this material over here at the base. Okay. Look at that, what that looks like. So it's a bit different from this one here, which is the cast object. But once you've done that, then you can do an in-canvas render, which actually takes all of these, the scene and the appearance properties, and renders it in several iterations, and that's basically how ray tracing is done. So you can go up to, say, what's called an excellent iteration, or you can go all the way to final. Now, as you can see, it's taking, should take about 60 seconds if I remember correctly when I did this the other night. You can do that, or while it's actually doing that, you can say, I want to render this on the cloud. So when you render it on the cloud, you can use local rendering, or you can render on the cloud. And based on several presets, so whether you're publishing to the web, or maybe what would be the highest end would be the printing. So if you're publishing it to an 8.5 by 11 image, which is 300 pixels per inch, it's going to consume 8 cloud credits, and the render queue time is less than 10 minutes. Okay, and when you hit render, again, that submits it to the cloud. So you've got that image over there. It's starting to render as well. It hasn't reached that excellent stage yet. Now, when you're doing in-canvas render, any motion or any orbits will reset it because it's basically starting from scratch. But I've got several images here, or at least one image that I pre-rendered yesterday. And if you look at the quality of that, I'm not quite sure if it goes through accurately with the GoToMeeting, but it does have quite detailed rendering. If you have a look at that, it almost looks like the real material there. Okay, and now that's our rendering environment. Now, last but not the least, we also have data management in Fusion 360 built in. Now we have version management, which means that every time you save your model, a new version is created. And because all of your data is in the cloud, this enables live design reviews. I'll show you what live design reviews means later, which means that you can send the link to someone and both of you can see exactly the same screen at the same time. So any manipulation that you do on your model or any comments or markups, you can actually do, the other person will also see that. There's the ability to do commenting and redlining. You can access any of your models via A360, which means that you can access it via desktop or a mobile device. And which is something that I find really cool as well, is the ability to export it to various file formats. This typically means that, I guess, if you've sent files out to other people, you might be asked to send them out in a specific file format. So you export it, save it into SAT format, you send it to the guy, and then the guy says, oh, I can't open that, then you save it in another format. With Fusion 360, they can actually access it to A360, and they can download that specific format for themselves. I'll show you that in a while as well. I'm going to open up the break assembly in Fusion 360. So I've got here all my models, my data sets. So for example, for this gearbox, yep. So it's opening that up right now. I should have just left it. But anyway, what you could do, let me close this gearbox down. But what you could do is actually open up, see the different versions, and you see the different versions for that particular file. And you can either promote that version, maybe you want to go back to that, roll back to this particular version. You can promote this to be the latest version, or you can just open that version for your viewing purposes. Okay, so that's now opened it. But then you can also, again, access this not just by, Fusion, but if I go onto this website here, I've got my Fusion 360 or Fusion 360 team website, which means I've got different projects, and you can assign individual team members for every project. So for example, if I go into this custom data set, the project members I've got there are basically myself using my CADGROUP email and my other email address. And you also have, for example, your projects or the files inside your project. So I'm just going to go to break assembly, and I'm going to go with this one here. So I have here my front web page for this particular model. And I can have a look at, if I click on this, let's have a look at that model within A360. Again, you can share this link with anyone, and they can actually view this model as well. And what I've done is I've made some comments and markups. So if I click here, okay, I can add comments to objects, or I can see the comments there. So I've made 2 comments here. The first one, if I click on it, it actually shows me that balloon there, or that marker there. If I click on this, there's a red line. If I wanted to create my own comment, so I can, I should say, I should be able to reply to that. And this record is basically saved into the project so that you have a history of what's been said and what's been done. So you've got markup tools. And again, I can create a markup cloud here. And so you can add text there. Okay, save that, and down that's going to be saved as a particular, oh sorry, it's over here, that particular comment there with its own number. You can even explode this if you want to see it in more detail. And that's all done dynamically. I didn't have to make any prior explosions inside my Fusion 360 model to do this. Now, as I was saying earlier, we also have the capability to, once we send this link to someone, they can click on this one here, which allows them to export this and download this. So they can download this into that specific format that they want. So you don't need to fuss about what format they need. Just send them the link, and then they can download it as SEP, STAT, or even as an inventor file. Or basically, this will download it as an inventor assembly. And once that export processing is complete, then you'll get an email notification that says that export link is complete, and then you can send that over to the guy, or they can download it themselves as well. So that's basically within the Fusion 360 session. Also, with while you're in the Fusion 360 environment, you have access to, for example, any renderings that have been made or any simulations that have been made. For example, if I click on this, it'll show you specific simulation results that have been made. Okay, so based on that temperature, it's the undeformed model. Okay, it's not. It shows you all the constraints that have been added. Shows you the heat flux as well. So it shows you the results of any of the simulation studies that you've made, all within the Fusion 360 environment. And I should actually go back here and show you that all of these components, because they've been brought in from Fusion Direct, in fact, it's not really brought in, it's already there in Fusion. You've got that design tree where it shows you the tree of the model of those individual parts, and you can interrogate them as well. So you can have a look at the properties of that part. Okay, if those have been assigned mass and volume of that particular part as well. So all of this within the Fusion 360 environment. Now, if there are any related items there, so for example, if I open up, I think it was the grid vise or the grinder vise. So it shows you that all of these files are currently in use by myself in Fusion 360. But that doesn't prevent any other user from actually looking at any animations that, for example, have a look at this particular view of the storyboard. Okay, and then they can hit play, and it's actually doing all of that inside the Fusion 360 environment. So no file exports, no sending of, sending that video file. Everything is accessed through Fusion 360. So that's whether it's, for example, animations or any rendered images that you want to have them view. It's all inside Fusion 360 team website. Now, one thing that I find really cool as well is what we call the live review session. So I'm just going to dock this here, and I'm going to open up, for example, if I open up my brake assembly? Okay, let's work on the grinder vise. Okay, minimize this, dock that to the left. Now, what I can say is that, okay, I want to start a live review session of this particular image. Okay, I think it's because, let me just choose something else. Let me save this first. Sorry, that's why it's not, because I'm in the render environment. Okay, let's do a live review session. So what happens is that it generates that link. It's opening up the live review environment. Okay, brought up this dialog box, and I can send this link to another person. So I'm just going to paste that there. It's initiating the live review session. I can put in my name there. Hit start. And once I have that, bear with me. It isn't popping up yet. refresh that. Am I just being impatient? There you go. So basically what I can do is now I can start commenting, and I can say, hi Dan, on one screen. I get notification that that comment has been made. And then any orbits that I make here, if you notice, it's also reflecting there on that browser session over there. And so Dan can also make the comments on his own. The base. So I can go in here and basically say I just want to be able to look at that particular model. And as you can see, my crosshair, my mouse pointer is actually reflected on that other screen as well. So if I wanted to create something here, let's say I want to isolate this, that actually isolates it there as well. Now I'm going to unisolate. So you can also send the control to Dan Designer. And so Dan Designer will be able to, oops, the unisolate still hasn't gone through yet. Let's refresh this. Ah, he's left. But that is how you do a live review session, where you've got all the chats there as well. Now all the chats here unfortunately are not necessarily saved into Fusion 360. You don't have a chat history here as well. But again, it can be controlled by Dan, and we should be able to see how Dan, that's strange, it still hasn't shown us the full model. Anyway, okay, show all objects. Okay, that's strange. Anyway, not good to end on that note, that it's not working as 100% as expected, but that's what you do when you're working with cutting-edge technologies. Now, I've got to move this forward. We've just got 5 minutes left. Now, Fusion 360 right now comes in 2 flavors. We've got Standard and Ultimate. So the main difference between Standard and Ultimate is that Ultimate has got advanced simulation like buckling, nonlinear analysis, event simulation, shape optimization, and advanced manufacturing, which is probing, positional, 5-axis positional, 4 and 5-axis simultaneous. Okay, now you can have a closer look at the differences if you go to autodesk.com/product/fusion-360/subscribe, or just go to the subscribe site, or just give us a ring and we'd be glad to talk you through what the differences are. Now, if you are a current subscriber of Autodesk and you've got a product design suite, if you've got product design suite right now that's on current subscription, you do have access to Fusion 360 Standard. Oh, sorry, one thing I forgot to mention here earlier is that Ultimate subscribers, Ultimate Fusion 360, does have, you get 1,000 cloud credits included with the subscription as a one-off gift. Okay, now current subscription customers, if you've got Product Design Suite Premium, you have access right now to Fusion 360 Standard. If you've got Product Design Suite Ultimate, you have access to Fusion 360 Ultimate. If you've got the Product Design Collection, you have access to Fusion 360 Standard. Now, you don't get any additional cloud credits for this. What cloud credits you have for your suite, that's what you can use for your Fusion as well when you do your cloud rendering and your simulation. All right, that basically is the end of the webinar. Thank you for sitting through that 1 hour. If you've got any questions, please feel free to, oh, sorry, before I actually end, while I open the floor to questions, can I just put in another poll to see if you'd be interested in looking at future or more specifics into Fusion 360. So I have here some aspects of Fusion 360. If you could let us know if you're interested in looking at more webinars on it, that would be great. Okay, now while that's happening, I'm going to open the floor to any questions. So if you've got any questions, please feel free to just type it in the chat page and I don't think I can. Okay. Yep. Great. Let's see. Leaving the floor open for a bit more questions. Have the poll open for a bit more. No, I have the poll there. Yep. All right. Seems that it has evened out already. So a lot of people want to see basically 3D modeling, simulation, and CAM. All right, great. So thanks for answering that poll. Again, I'll leave the floor open to any more questions for about 5 minutes, and then I'll end this webinar. But if you don't have any questions, thank you very much for attending, and hope to catch you soon in another session. Bye. Just trying to get these. There's some questions here appearing. Just trying to get access. I'm double clicking on it. Just bear with me. I guess I can see that there's some questions here from John, Joshua, Wang, but for some reason, I'm not able to access those questions. Hold on, let me just try this. That's strange. Oh, there we go. Okay, yeah, Joshua, thanks for your question. Yep, we'll go more into the drawing environment in Fusion 360. I will say, though, that the drawing environment, it's quite good for the basic stuff. There's a lot of stuff there to get you the detail. But if you really want to get more into detail, you can actually do this in either AutoCAD. But again, there's a lot of drawing environment enhancements coming up for Fusion 360. John, yes, there will be a link to this webinar. We are